are really with us. Dipinder, good afternoon. Okay. Right. So we have Priyan, we have Arun. Thank you all of you for your messages. I'm just let me do some of the setups and then I'll talk about what we are going to do today. All right. Okay, I've started recording as well. Manisha, good afternoon. Yes, so if those who are just joining in can just leave a message, chat message. And as I have repetitively said that just make it a habit whenever you have you join a meeting or just whenever you're just joining a meeting, always try to give a message so that we know. Okay, so yes, this is our week 5, and today we are going to have like live session with this section 7 for today. And next week it would be with the section 9, by the way, on Thursday. So yeah, before that, you have a quiz today. So for your section only, what I'll do is that we'll just do this lecture. And when we are done with the lecture, I'll just give maybe half an hour or an hour. And then I'll start that one and I'll open for again for 4 or 5 hours window. No worries about that. But again, it will start when we are done with our lecture. So be here. And again, it's something that you will be doing afterwards after our lecture. So be here and you will have to implement do that. So let's start today. Today, as I said, it might not be a that long session, but we have few interesting things to discuss. And those things are we have normalization that we started last week. So can I have a quick feedback from all of you that how many of you were able to just see the last week's lectures? Because again, it's unless you will see that, of course, as I told you, that you might not be able to attempt the quiz because I would be asking some questions that were practically being discussed in the session. So may I ask that how many of you were able to just look at the last week's lecture? Did you guys see that? Because you will understand that what will be different today and how we are just talking about that one. So how many of you were able to see that lecture? Yes or no? Depinder, wonderful. And how about others? Jay, thank you, Jay. Yes, this is good. And else, who else was able to see that last one lecture? So I see only Depinder and Jay have mentioned here. Okay, Arshit, wonderful. So again, just a reminder before we start that you need to look at them to solve the quiz, because as I said, I might be asking questions. Not might be, definitely I'll be asking questions specific to that class. And specific to that class means those who would have looked at the recording, they would be just basically able to answer that. Otherwise, they might not be able to answer that. Anyhow, let's start talking about our this week's lecture. So it's week 5, and we'll be talking mostly about normalization. And again, those who have seen the lecture, I see 4 names, 4 names, rather. It's Dipinder, it's Jay, it's Arshit, and Manisha. So we have got like these 4 or 5 people. So a normalization was something that we started last week as well, and we have talked about a little about that before as well. But today we'll just see another example, and we'll try to just solidify the concepts that we have learned previously. So let's start talking about that one. So data normalization. The normalization is a primary tool to validate and improve a logical design so that it satisfies certain constraints that avoid unnecessary duplication of data, and the process of decomposing relations with anomalies to produce smaller, well-structured relations. So actually, this is normalization. And what we do is that we will be just trying to avoid unnecessary duplication of data. So, okay. So then we just talked about, just wondering that if Oh, this was something. If I just, let me just see that. Was that something that we have discussed last week? Because I think this was the one that we had already discussed. Let me just see that. Um, okay, I'm just looking into that. Maybe I think I missed out, or maybe if I'm just repeating that one, I'll take care of that. This is section 7, right? So this is section 7, and this is about week 5. And what was in week 4? Let me just go there. And we had this lecture 4. I'll just have a look at that one. Yeah, so last week lecture was this one. And I was just wondering because we discussed a little bit of normalization over there anyhow. So yes, so we'll just talk about normalization and, well-structured relations, a relation that contains minimal data redundancy and allows user to insert, delete, and update rows without causing the data inconsistencies. So actually, our purpose is to avoid anomalies. There are different anomalies that happen when you are having data. So it might be insertion anomaly, it might be deletion anomaly, and it might be modification anomaly. So if you look at that, adding new rows forces user to create duplicate data, deleting rows that may cause a loss of data that might be needed. Modification is changing data in a row, forces changes in other rows because of duplication. So again, we want to just avoid all them. And we'll see an example. General rule of thumb, a table should pertain to more than should not pertain to more than one entity type. One entity type per table should be used. So this is an example. First of all, is this a relation? If you look at this table, so this table is that a relation? So answer is yes, unique rows and no multi-valued attributes. We have just unique rows for everything, and we have no multi-valued attributes. Even though we have got some rows which are empty over here, but still we are looking into something that, we our like our this table, it's basically called relation. Does anyone remember what is a relation? So a table is a relation when it has unique rows and there are no multi-valued variables. That is something that we discussed last time, that a table is basically considered as that one when it has a unique row. So yes, it is a relation. And what is the primary key? What is the primary key over here? Primary key might be composite over here. And what that might be employee ID and plus course title, because here employee ID is not unique in this table. Do you see that? 100, 100, 110, 110, 150, 150. So it means that multiple employees are like, mentioned with this, with a different, like same ID. So this cannot be a primary key. So if this table has any primary key, that might be the combination of the ID plus the title of the course. Why? Because the courses are different over here. Make sense, everyone? Courses are different over here. So that's why if 100 is combined with SPSS, for example, this record will become a unique record. Otherwise, ID is same, Margaret Simpson is same, department marketing is same, salary is same, and just the course is different. So if I cannot differentiate them if I take only one value from out of it. And who is that? You want to say something? I think it was Kashyap. Kashyap, you want to say something? Okay. I don't know what's going on. I do not even I did not hear you. Can you write in the chat window? You are asking a question?
No, sir.
Okay, thank you. So yeah, so we have got
Sorry, sir.
y-
Sorry for
yeah,
interrupting you.
yeah.
Sir, Sunana, I guess Sunana is a student of our class, section 8, section 7, sorry. I guess she's not in the teams and she's asking me to join the class, but she cannot able to get the link. So
Oh,
how can I help her?
I see Sunena here in the chat in our window. Can you do you see this team window right now?
Yeah, but she's saying that she cannot see you or can hear anything.
Oh, she cannot see or hear anything. Sunena. And where was Sunena before? Because I had so many times I asked how many people are there in teams, and I'll just
Yeah,
add.
like I
I'll
don't
just
know
need.
what happened.
Okay, I'll add her. Just be with me, and I might need her. This is section
It's
7. If
section
you
7, yes, sir.
so Sunena. Sunena 0263. Is that her ID? Because
Yeah,
we have.
Um,
I got the
yeah.
links. I got the link. I don't know. I was trying very hard to join the group. I wasn't able to join.
Okay, Sunena, did you attend any of the class before from like this any other class? Because we had a live class
I
last week.
tried to actually I tried to attend at the one class, but I don't know. I couldn't join that, and then I saw the recordings and which you
Okay.
gave.
Okay, right. So Sunena, I've just added you to that recording. I added to the team,
Okay.
and so that's basically that would be there. You should be now able to see the chat and everything as well.
Yeah, yeah, sure, sir. Thank you
Okay.
so much, sir.
Okay, no problem. Yeah, so we are talking about this primary key. So yes, primary key will be composite of these two because this table does not identify uniquely only the ID because ID is repeated. Now let's come back to second one. So anomalies in this table. What are the anomalies in this table? Insertion cannot enter a new employee without having the employee to take a class. We cannot enter a new employee over here if the employee has not taken any course before. So that's an insertion anomaly over here. And then if you look at that, what is that deletion? If you remove employee 140, we lose information about existence of tax account class. So if 140 is removed, we have just one record for this tax accounting class, and this tax accounting class or this course will be gone from here because we have got only one record for that one maybe. So if we just remove this 140, we will have this tax accounting is gone. So again, this is deletion anomaly. Modification giving a salary increase to employee 100 forces to update multiple records. So at 100, we have Margaret Simpson. If you want to just give the salary increment over here, what will happen is that we will have to make change in multiple fields, and that is updating or modification anomaly. So why do these anomalies exist? Because there are two themes, entity types in this one relation. This results in data duplication and unnecessary dependency between entities. So again, this is why, because there are two types of things over here going on. One is employee and its employees information, marketing information, salary, and then a course information. So clearly we can see that there are multiple entities and that are causing this anomaly of the sort over here. Now, how to solve them? Functional dependencies and keys. We have functional dependency, the value of one attribute, the determinant determines the value of another attribute. Each non-key field is functionally dependent on every candidate key. So that's an interesting one, because each non-key, we will see that every non-key which we have, they are dependent on the separate independent keys. Now, first norm of all, no multi-valued attributes. Every attribute value is atomic. There is no multi-valued, and they're atomic as well. You cannot further subdivide. For example, whenever there is an address can be further subdivided into street, city, and country, and whatever. So if there is any attribute which is not atomic, which is basically multi-valued some ways or others, we cannot have that table in a one normal form, first normal form. And that's the problem. All relations are in first normal form. We have talked about that. All relations or tables are in first normal form. Now, if we look at that over here, so now we have 1006 and it has multiple products being over here. So this is customer name and customer name, customer address, customer ID. So again, if you see that, this is not a relation. And why it is not a relation? Because if you look at that one, that it has multiple records of particular things. If you look at that one, it has multiple records of that particular. So this is why it's not a relation. If I come here, look at that. When I have just combined them into each individual record, now it has not it has become a relation, but not a well structured one. And why it is not a well structured one? Do you see the repetitions? A lot of repetitions over here. 2410, 2006, 1006. Same things are repeating. for no reason. Customer ID is exactly the same, but it's you see that till this part, everything is repeated for no reason. Make sense, everyone? So it is not a well-structured relation. So what we need to do is that we have anomalies in this table. And why this anomalies? If new product is ordered for order 1007, existing customer must be re-entered, causing duplication. So if 1007 customer or ID is another record is being added, we will have to have a multiple records over here, because this is basically for furniture, this is product ID, and over here. So we might have to basically do that. If we delete the dining table from order 1006, we lose information concerning this item's finish and price. So if dining table order, if you look at that, if this is deleted, so we get lost of 802. Why? Because the price and everything that just goes away, because basically now we don't have any information of that one, that price or things are there. So that is an anomaly. Updating, changing the price of product ID 4 requires updating several records. That's very true. If in this 4, the product ID 4, which is entertainment center, if I change the price from 650 to something 700, so I'll have to just change all the records where ID is 4. So that is updation anomaly over here. Right? So now second normal form does what? Take the table. It has to be in one normal form, first normal form, and every non-key attribute is fully functional or dependent on the entire primary key. This is very interesting. Every non-key attribute must be defined by the entire key, not the only part of the key. No partial functional dependency. What does that mean? Look at that. Look at that over here. We have got this one. So now if you look, order ID, order date, customer ID, customer name, customer address, and then product ID, product. If you look at that, this product, this looks like from this point to this point, these are partial dependency. This is product. And this is partial dependency. This is order. This all is the order. Right? So now if you look at that one, and here transitive dependency is what? Customer ID, name, and customer address. This will be repeating for no reason. In every record, ID, customer name, and customer address will be repeated. So they are just making a transitive dependency. And what is this full dependency? If you talk about, they are ordered quantity and the product ID and the product look like order ID. So if you look at that one, these are the full dependency, because I would be always needing an order ID and product ID and product quantity. So therefore, not in the second normal form. How to bring that in the second normal form? Look at that. That is very interesting. Now it is in the second normal form. Sorry. Second normal form. How come? Order ID, product ID, order quantity. We have just make that separate. Product ID, product description, product finish, and unit price separate. Order ID, order date, customer ID, customer name. Still transitive dependency is there. But do you see that partial dependencies are removed? Are you guys getting that one? So we have taken out order as a separate one, right? And if you look at that, product as a separate one and order ID with the customer name as a separate one. Now what will happen? What will happen now? Now what it will do is that partial dependencies are removed, but there are still transitive dependencies. And when we remove transitive dependencies, it becomes third normal form. Let's come back over here. 2NF plus no transitive dependencies. We need to remove the transitive dependencies if we want to have a data in a third normal form. Make sense, everyone? So what is that? Note, this is called transitive because the primary key is not a determinant for another attribute, which in turn is a determinant for third. Look, I'll just show you example. Solution: non-key determinant with transitive dependency go into a new table. See here, we'll create a new table and we'll pass that non-key attributes. Non-key determinant becomes primary key in the new table and stays as foreign key in the old table. Now see here. To remove that dependency, the part transitive dependency. You remember what was the transitive dependency over here? That order date, order ID, customer name, customer. These three things were repeated for no reason with every order. So if there were hundreds of order from one customer, so ID and customer name. Are you guys getting that one, Ignatius? It would have repeated with that one. So removing that transitive dependency, we took out order date, and customer ID over here, right? And customer ID has become a foreign key over here. Now see how we have removed that one. Now the customer can thousands of orders. We won't be repeating customer name and address. Can I have a thumbs up from everyone? Do you guys understand this transitive like removal? That we have removed the transitive dependency, and why? Because the customer name and address would have been, would have been used for no reason. There was no reason, there was no requirement, and the customer name would have been used. Make sense, everyone? Now, I just see Daniel has responded. Wonderful. So merging relationship, view integration, combining entities from multiple ER models into common relations. We can combine them, and how you do that. Issues to watch out for when merging entities from different ER models. When we are combining multiple things, we have to keep in mind some of the issues. What are those? So issues to watch out when merging entities from ER model: synonyms, two or more attributes with different names but same meaning. We have to look at that. There should be no synonym attributes. Like again, an attribute that has like they have name difference, but in essence they are same. So we have to just avoid that one. Homonyms, like attributes with the same name but different meaning. There might be same naming but different meaning. They have different meanings altogether. Transitive dependencies, even if the relation are in 3NF prior to merging, they may not be after merging. After merging, after merging relationship, we might get 3NF being disturbed. So after merging, it might be the 3NF is again disturbed. There is a transitive dependency being produced, and we have to actually handle that transitive dependencies as well. Supertype subtype relationship may be hidden prior to merging, and there is a supertype subtype relationship that might be hidden before that one, and they are there. So now enterprise keys, primary keys that are unique. So enterprise keys, primary keys that are unique in the whole database, not just within the single relation, corresponds to with the concept of an object ID in object-oriented system. So again, in object-oriented system, let me just show you. In object-oriented system, we just talk about this type of that thing, that the candidate ID or the primary keys are unique for whole database, not just within the single single table. So that is very interesting, because what we say is that primary keys that are unique the whole database, not just within. So as that type of primary key that we have created for particularly for whole database, that is called enterprise key. Are you guys getting that one? It is called enterprise key, and enterprise key means that they are enterprise keys, and they basically make that particular field over here. Make sense? Corresponds with the concept of an object ID in object oriented. So when we have this object oriented systems, that would typically mean that we have got some of that, like that enterprise keys are typically being mentioned over there, and we just talked about this one. Make sense, everyone? So we'll just talk about this, and we have just talked about some of these things before, relationships and all those kind. Now let's come back over here. Okay, so look at that. Enterprise keys: object ID, object, employee OID, customer OID. These are enterprise keys. And why they are enterprise keys? Because in whole system, in our whole database, they will always remain same. You see here, OID for object. OID is 1, 2, 3, 4, 5. So it's being defined over there. Now this OID is used over here in employee. So we have know that it's an employee. We are note that this is an employee, and we are just mentioning that one. And the customer is 2367. If you look at it over here, 2 and 367, they are all the customer related thing. Make sense, everyone? So that is basically relation to enterprise keys, sample data with enterprise keys. We can just mention that enterprise keys and thing. So these are few things that we have, again, as I told you, that we have less discussed before that one. And also those who looked at the last week's lecture, we started join there. And today I've included a very graphical representation of joins. Those who have looked at the lecture, do you remember that we have done joins over there? And today we'll just look at that one, and we'll just do some aggregate functions and joining over there as well. Last time we had this join, and we have the code of that join as well, and you can have a look at that code. So inner join is when we have two tables and we are just looking at the data which is being combined and in both tables. It is in both tables, then we say that it is called inner join. Make sense, everyone? That is in both tables, and it is called inner join. In the same way, if you just move forward, I'll just show you. Okay, just give me a second. All right. So let's say this join. So whenever there is a join, in fact, typically we will say that this is basically called as inner join. And left join, when we have two tables and we just take all the values from the left. And again, last time I've given the examples, but I'll just do that some repeating examples over here. Right join, when you take all the values from the right one. So you take those which are intersecting both, and then you take what which is basically over here, which is all the way with that one. Full join is basically when you have that everything being joined together, right? Okay. So look at that inner join, matching values from both tables. Select table one, table one, column two, table two, column one, table from table one. Inner join with table two, when table one matching column name is equal to table two. And you remember we have given enough examples of that one before. The left join on the left outer join returns all the records from the left table and also all the records which satisfy a condition from the right table. So that is called left join. So left join means take everything from the left table after the joining. After the joining, and we have seen enough examples of that in last class. Syntax of syntax here, table one, column one. And what we do is that this is basically, this is called left join. And the left on the left side, whatever is on the left side, which is table one, we'll get all the fields, whether they are matching or not with that one. Like they do not have a matching record on the right side. We will still receive that one. Right now, right join. The right join returns. So again, that's the just the opposite of the left join. We will have the right join where we can talk about that it is basically we take everything from the right side of it. Like right side of it, we'll just try to take everything from them. Then we have this this right join syntax. We use the right join over here. And in the same way, we have full join. The full join or the full outer join returns all those records which either have a match in the left table or right table. So full join means again just provide everything that is there. So if you look at that definition, a full join means everything. Whether they are matching or not, you have to represent everything on that one. Make sense? Okay, so there is a question. I would like you guys to answer that, and I would like everyone to answer this one, by the way. What is a natural join and when it is used? Again, I would allow you to just Google that and come up with that one. What is a natural join in queries? When we say natural join, what is a natural join for the queries? Yes, I would like everyone to answer over here, not anyone. Yes, I'm waiting for the response from you guys. Natural join. Wait for maybe just Google that and come up with that.
So do we have to speak or do we have to write in the chat?
Write in the chat.
Okay.
I'm waiting for the answers, right? And J, in most of the cases, the tables are joined. So what is how it is different J from the others? Joined in what way? That's the question. The $1 million question is joined in what way? Common columns. Okay. So then what is the difference between this one and inner join? So you say that it's a type of join that allows us to combine rows from two or more tables based on columns with the same name and data type. Okay. Okay. Sivaji, that's look good. And I need more definitions, maybe. Some more definitions, maybe. So Jay has replied, Sunaina has replied, joined, and Simarjit has replied. I'll be waiting for everyone's reply. Just try finding out and get back to this one. It used quality operator to match rows. Okay, quality operator to match rows. Interesting. Okay, natural join automatically join tables based on column names, while inner joins quite explicitly specifying that on or using on. Oh yeah, that's much nearer, Jay. Now you're reaching to the near place. Now you're reaching near. Now you're reaching somewhere. Okay, it allows you to join rows from two tables with the same column names. Deepinder, yes, this is right, but let's say. Okay, automatically join based on. So yes, so the nearest definition or nearest thing is again from J, it's natural join automatically join tables based on column names, while the inner joins require explicitly specifying the one. Wonderful. So now, yes, how many of you have replied here? J, Sunaina, and Simarjit, and Deepinder, and Manisha. Natural join automatically join based on columns. Well, you have to specify them. Wonderful. So that is basically, what is that natural join? And natural join basically does what? It's automatically, it just joins the same name column and, just generate them. Now, if you come over here, natural join, look at that. Here is the natural join example. Here is the example. When you want less columns, so they will do what? If the columns are repeating. So column one, column two, column one, column three. So column one is repeating. It will just take it away and it will just take out the column one. When we have the inner join, typically inner join, I'll have column one, column two, and column one again. But in natural join, do you see that column one, column two, and column three? It just combines with that one. Manisha, does that make sense? When you want less columns, it will just combine with them and it will just, give the less columns over here. We will have less columns over here. Okay, wonderful. So this is natural join. Now let's come back. Self join. When you join a table with itself, but use different aliases as their name. It is mostly used to compare different rows in the same table. It is not base type of join, since you can do inner or outer joins with a self join. It's not a base type of join, since you can do inner or outer joins with a self join. So, it's basically self join when you are joining a table with itself, the repetitive type of thing or the loop type of thing. That when you are joining the table to the itself, to itself, you're just joining the table. That would be basically what our that one, right? So now let's come back. Many to many relationships. Many to many relationships are basically formed by using multiple joins. And that's an interesting fact about this one. Many to many is typically the multiple join. And multiple join means that we will have the multiple joins being used in the many to many relationship. So if you see multiple joins, you have to you have to quickly know that this has multiple joins and it has many to many relationships between each other. Right. So now let's move. Okay. So views. This is another very important concept. Views used to focus, simplify, and customize the perception each user has for the database. Views are very interesting. Views are what its name suggests. Actually, it refers to those like type of things that would customize and specify, simplify the view for each user. We have talked about that it's not a good idea to use select static in a statement, in a query. Select static is not a good idea. Why? Because we know that we don't want to show all columns to all users. In the same way, if we talk about that, I want typically some users to see, or some users to show something that typically is just for their use, and it's not for anyone else's use. You know what I mean? So if we have got something like that, what we do is that we will try to use that views. So for a data entry operator, there will be a different view for the database. For for a manager, there will be a different view. For a CEO, different view. For CTO, different view. So that's basically what views are. So views to focus, simplify, and customize the perception of each user has for the database. Now can be used for security mechanism. I told you security mechanism. Why? Because by allowing users to access data through the view without granting the users permissions to directly access the underlying base tables of the view. Are you guys saying that? It's a sort of a virtual view being created, virtual table being created. It's typically called as virtual table, by the way. Virtual table is created that will save us, from looking at anything that from showing or from disclosing anything that we want to hide from the user. For example, is it a database entry operator? And I want to save for example, I don't want to show typically, for example, salary field of a particular database. So I'll create a view. I'll create a view where I will never include the salary, and that view will provide data when our data entry operator is basically working on the database, and that would he or she can only access that particular virtual table that has been defined for them. Instead of everyone having access to everything, we want to put some access to some people. Displays one or more database records on the same page. So it will view, it might bring up the record from one or more tables. Again, by joining, by combining, it can bring any number of data tables, like data from the data tables. So it can bring any number. Now then, a key to creating useful database is a well-chosen set of views. This is very important. We need to select proper views for the database if we want to create a good, useful database. Are you guys getting that one? Views are actually virtual tables that we create for particular users, and we don't want to show them everything. So that's why we'll just, we are not giving the permission to access everything in the underlying base tables. And for that reason, what we do is that we will just create views for that one. Now, all aspects of a view can be customized. A view can be created and customized in a number of ways, numerous ways. Name of the view can be changed. Customize fields that appear in the view. I wanted to have first, for example, name and age. Now I want age and, for example, email address or something. I can typically customize that as well, right? So the column title for each field in the view, the order of the fields in the view, the width of columns in the view, as well as the overall width of the view, the set of records that appear in a view, filtering, the order in which records are displayed on the view, sorting and grouping, column totals for numeric currency fields, and totaling and subtotaling. So these are all views that we would like to work on. Now, ways to create a new view in database, and how to create a new view. We'll just talk about that one as well. Create a new view from scratch. or make a copy of an existing view and modify it. So we can, again, we can have multiple purposes. It can be a purpose where we want to create a new view, or we want to just, access a view and just make a copy of that one. And after making a copy, we just create that typical thing, right? So that's typically what it's um, the thing that, like, again, we have character and the types of views that we have materialized view, we have simple views, we have complex views, we have dynamics views. We'll talk about some of the views and we'll just make them. So materialized view is a replica of target master for a single point in time. Materialized view. Simple views are created for tables and are used for creating secure manipulation over the tables or structure of the table. They're simple views. Complex views, on the other hand, you see complex views are different. Views of type which may comprise of many elements such as tables, view sequences, and other similar objects of the database. Dynamic views, virtual tables. This is really interesting. Dynamic views for which data is not stored and the expressions used to build the view are used to collect the data dynamically. Is that making sense to everyone? Dynamic view will be one that does not, collect the data in the beginning, or what it will do, it will just, collect the data dynamically. Whenever it will be called, it will just create a virtual table and access the data from there. Whenever it will be called, it will just create the dynamic data and it will try to access that particular view. Make sense, everyone? So that is typically what? That is typically our, our views that we are talking about. And these views play a very, very important role because these, we will be creating the views and we'll be just, using the views for particularly those users that we don't want, that we don't want them to have that record of like particularly, we don't want them to access everything that they have. Make sense, everyone? So now let me just see. This is the slides. The slide. This one is over, and we have another slide that we'll just cover up. And that let me just show that one to you. And where is that? It's here. And let's go back to our week 5. This is our week 5. And this is the file that we'll be talking about today. So I'll just and this one. Aggregate functions, and I'll just share this one. So let me first of all share this slide as well, the one that I have just shown you, this one. I hope it is saved. Yes, it is saved. And let's see that. Okay, yes, I know it is in use. Any questions thus far from anyone? Yes, any questions thus far? Because we'll continue with this one, aggregates, but I'll do that maybe after a little short break. I will talk about this like aggregate functions, and it's a very nice practice of aggregate functions. Yes, anyone? Okay, what does silence means? It means that you have a question or you don't have a question. Interesting. I'm not getting any response. No yes question, no question. Okay, Simarjit, thank you. Okay, right. Wonderful. So let's take a break of 10 to 15 minutes and I'll be back. We'll talk about this one, and I will also give some other practice of that one as well, right? So we'll just do some of the practice. Let's take a break. and around it's 15 minutes break. I'll be back at 2 p.m. sharp, and we'll discuss a break. And again, I just heard from Simbarjeet, you, and no one else has just mentioned that whether they understand or not. Okay, right. Thank you very much. And I would just now stop recording because I'll just make it maybe 2 recordings, right?